And welcome again. This time we're in our final exercise in our Intro to Cassandra for Developers crash course, video 6 of 7. This is the execute CRUD operations. So the last link here, again, we're going back to our repo. Notice the #3 execute CRUD operations. Again, the link is in the video details. All right, so we left off at the end of 2. We created our table. Wonderful. So what we're going to do is go down to execute CRUD operations. Now, this exercise is probably the longest of the ones we've been doing so far. You know, originally we just kind of created our database and created a table, kind of going along with the videos you watch. Hopefully you watch the Art of Data Modeling, and now we're here where we're going to create some more tables. We're going to see more about our CRUD operations, our create, read, update, and delete type operations. And these are the type of operations that you're going to use in any kind of interaction from an application to a database, right? You're always going to have a case where you need to create things, where you need to read things, where you need to update things, and you need to delete things. So now we're going to go over what those commands look like. Okay, so the first couple things we want to do, if you remember, we talked a lot about comments by user and comments by video. So we're going to go ahead and create those tables just like we talked about in the video. Let's go ahead and create those. Again, now I am continuing on from what we did previously, so I'm already using the killer video key space. If for some reason you left and came back or something, make sure to do that. Otherwise, you're probably going to get some errors. Okay, so we've created our tables. Let's go ahead and describe them. Again, you can just copy the commands out of the command execute. And we see we have our 3 tables: comments by video, comments by user, and users by city we created earlier. Now, the first operation we want to look at is the C, the create, right? So when you create things in Cassandra, you're going to use an insert statement. Now, by the way, if you've come from the SQL and relational world and you're checking out Cassandra for the first time, insert should look very familiar. That's because it's the same thing. SQL is a subset of SQL. It looks and feels just like it, right? So yes, there may be some differences under the hood, like you don't join between tables or anything, but the syntax is largely the same, except for some commands that are specific to Cassandra. But for what we're doing now, this should all look and feel very familiar. Okay, so the first thing we want to do is insert some data. We have our tables, right? So we want to insert some data into our comments by user table. Now, something I want to point out here is that for those of you who are familiar with something like a UUID, you might be asking, why are we using these hard-coded UUIDs? Would I ever do this in the real world? The reason why we're doing this is for when we do our workshops and our crash courses and everything, we usually have lots of people who are doing them all at the same time. So it is much easier for us to use these hard-coded values. So if somebody runs into some trouble, we know exactly how to help them. If everybody was generating their own UUID, it would be very hard to track down. So my point of this is you're going to see a lot of cases where we're using these hard-coded values. However, in the real world, I would actually be using something like this, where I would use UUID with these parens. If you're interested in that, right, you can just go to the docs there. It'll explain all about it. They're extremely easy to use. Like you see where I'm using now with the parens, I would literally just put UUID with the parens to generate that on the fly, right? I'm not really getting into a lot of detail about what UUIDs are for and how to use them. Essentially, they are a way in a distributed system to ensure that you have unique keys, which is very important. If you're coming from the relational world and you're like, well, if I'm going to have a user ID, I'll just use an integer and then I will just increment that integer. And for a relational database, that's fine. But for a distributed database, where I have multiple machines, multiple nodes, if you remember from the very beginning of this course, then what happens is if I have, say, 2 users that are being created at the same exact time, and there's, say, a network partition and 2 nodes can't talk. Well, if I'm using integers and both users get created with an integer of 1, what's going to happen is when that network partition recovers and those 2 nodes can talk to each other, last write wins, right? So one of those is just going to disappear, and that's a collision. We don't want that in Cassandra. We don't want that in any distributed system. So we use UUIDs instead for IDs. That way I know from a distributed sense, my IDs are safe. I don't have to worry about those collisions. Okay, enough of that. So what we're going to do is we're going to grab all these insert statements. And we're just going to go ahead and put those in. We're just populating our data, right? You see this insert into comments by user. We're specifying the fields. Now, I purposely kind of like spelled them out this way to make it very clear what each one was for. In the real world, like I would probably more do something like what you see here, where I'm just listing out the columns. And then for whatever values or whatever columns I have, I'm now saying, okay, the values. So if you were to take a look at this, I'm saying the user ID value is this first one. A comment ID value is the now, right? So on and so forth. So they have a one-to-one relationship. And you can see that we're using now to generate our timestamp, and we've just inserted some data. Okay, let's scroll down a little bit. Let's go ahead and put some data into our comments by video table as well. And again, the idea here is just to give you a feel for how the insert statements work, right? If we look over on the side, you can see I have my insert into whatever table, the column names, and then values with the actual data. Okay, that's inserting, right? It's pretty simple. You can use an insert. You can also use update. I'll get there in a moment, but for now, create is insert. Okay, so moving on to read. Well, now we've put some data in the system. So how do we read it? So that's where you see this command, the select star from comments by user. I'll go ahead and do that. And look at that. Oh, I can read back all the data we just inserted. Now, something I want to point out, and this is very important. So if you were falling asleep at all, wake up at this moment, because what I'm just about to say is really key. The only reason why I'm even doing something like a select star from comments by user when using Cassandra without specifying a partition key in my where clause like I am here is because I know that we only have 4 rows of data and a couple partitions, and that's it. If you were to do this on a real Cassandra cluster with a real production data set, and I'm talking if you had a case of, like thousands or millions of partitions and rows, if you issue this, you would have just caused a full scan on your whole cluster. That's this little blurb I'm talking about right here. This is never something to do for real in your app, especially in a production system. Again, we are using a very small data set here, so I just happen we just happen to be able to do this. I just want to point that out. I'm not going to belabor it anymore. And if this goes back to what we talked about in the very beginning of this crash course with the way that Cassandra works. And again, it is, you always want to use that partition key, right? And that's what we're doing here. So in this example, we're doing the same thing, but we're saying, okay, well, I'm going to put the partition key, because user ID is my partition key in the comments by user table. But I'm going to put that in my where clause. And now I'm pulling back just that partition. Notice the difference, right? I get that single partition back compared to multiple. Again, I have a couple in this case, but if I was working with production data, I could have millions or billions, and you do not want to cause a full scan across your cluster. Okay, so we've just read some data. Pretty simple, right? Let's go on to some others. We're going to read all of the comments, all the data from the comments by user and comments by videos table. Okay, you can see that those came out. This is, again, based off the data we inserted earlier. So this is us reading with a select statement. All right, scrolling down a little bit more. Now let's go ahead and update. By the way, before we do that, I do want to point one thing out. We talked about the time UUID field back in the data modeling portions of the series here. Time UID is actually a really cool field. It essentially combines both a UUID and a timestamp into a single type, a single object. It's really nice and convenient, actually. So if you do have a case to use it, I suggest go ahead and use it. Okay, so now moving on to step 3D. This is where we're going to update some data. Now, if you take a look at what we had done previously, right? And we created some data using this insert statement. And we said, oh my God, that guy Patrick is such a geek, right? And in the data, here it is, right? You can see we've got that data right here. And if we take a look at the comments by video table here that we created earlier, right? This is the same one. You don't need to copy these. We've already done this. In order to update some record, we need to know what the primary key was to create the record, right? So if you take a look at the primary key here, you'll see it's video ID. So our partition key is video ID, and then we're clustering by comment ID, and this forms my primary key. So I need those two values, because if I'm going to update a column in that particular row, remember the primary keys, they do what? They determine, a unique row. So if I'm going to update some column in a row, I need to give it the exact address to where those things are. So I need both video ID and comment ID. So what we're going to do here is notice in our statement, I have both in my where clause. So I'm going to say update, the table name, comments by video. I'm going to set comment. I want to change the comment. So it's existing right now. It is, oh my God, that guy Patrick is such a geek. And we're going to update it to, oh my God, that guy Patrick is on fleek, right? But notice what I'm doing in the where clause here, where video ID is that ID and the comment ID. Remember our primary key is a combination here of video ID and comment ID. So I'm passing both of those into my where clause. So I'm essentially saying, hey, update the comment column specifically for this row with video ID and comment ID. Okay, let's go ahead and do it. Okay. And notice I did a select statement right there after it, so it does select it, and now you see that that has been changed to, oh my God, that guy Patrick is on fleek. So we've updated the data from one value to another value. All right, so then moving on to delete, the D in CRUD. So we're going to delete some data. I'm going to just scroll down. Now, one thing I want to point out about deletes real quick, right? And I kind of talk about this right here. So in Cassandra, when you delete, you're actually inserting. Now, if you want to, you can look up what are called tombstones. As a matter of fact, if you go, and I'll talk about this here in a minute, if you go to any of our free online courses where you really get into the deep fundamentals of Cassandra, you'll definitely find out about tombstones. So Cassandra is built to perform at scale. And it's also built in such a way to ensure that when you do insert, and I'm talking, this is a petabyte level database, you could have thousands of nodes. And when you perform a delete operation, it's actually creating what's called a delete marker tombstone. And that is an insert on its own. Now, why am I telling you about this? Well, because how you delete matters, right? So if, let's say that you had a table that had 1 million rows in it, right? Would you want to delete, and let's say you wanted to get rid of the whole table. Right? Now, if you knew you wanted to get rid of the whole table, the way to do it is to use truncate, right? If you're like, okay, I just want to drop everything from this table, use truncate. That is the most efficient operation from that standpoint. However, if you just wanted to say delete a subset of the data in that table and you wanted to delete a set of partitions, then you want to delete at the partition level, right? Now compare that to deleting every individual column of every row if you had like 1 million rows. I mean, other than that being just a little nuts, you would actually be creating a delete marker for every single one of those columns instead of one delete marker for the partition. Huge difference there, right? So my whole point is this, in my little tangent here, is when you're deleting, delete the largest set of data that you can at a time. If you know you need to delete the partition, delete at the partition. The only time you should delete an individual column is when you really truly need to delete just an individual column, right? You keep that in mind, you'll be totally good. Okay, so moving on, if I want to delete something, I just issue the delete from command. So I'm going to say delete from, again, my table name, comments by video. Again, notice I'm providing both the values that are in my primary key, so in this case, my partition key of video ID and my clustering column of comment ID, because I want to ensure in this case that I'm deleting this row. I'm deleting a specific row. If I, by the way, just did this and I did not do by comment ID, I would delete the whole partition, right? You see how that works? So I can choose. So what I'm going to do is I'm going to delete just the individual row, most likely the one we were working with. And look, boom, that one that, oh my God, that guy Patrick is on fleek. You'll see that that is now gone because we selected it back out as we were done. So I have effectively deleted that row. Okay, that's awesome. Thank you so much for joining me through this crash course and going through the exercises. I hope this is just the start of your journey with Cassandra. There is so much you can do with this database. It is just so capable and can perform at scale like no other database out there today. And finally, If you want to learn more, if you want to dig deeper, don't forget to go to the DataSex for Developers link here. That'll bring you to datasex.com/dev. There are all sorts of things to learn, free learnings and everything that are there on that page and help you get a little bit deeper into your Cassandra knowledge. And then don't forget, we do have one last video, and I'm going to bring you into some resources that you get to check out. And thank you so much.